Hi friends, this is Prashant. Today we are going to start with Calorimetry Part A Numericals. Right? I'm using 2020 textbook, that is 7. First numerical. By imparting heat to a body, its temperature rises by 15 degrees Celsius. So your delta T is given as 15 degrees Celsius. What is the corresponding rise in temperature scale or on Kelvin scale, right? So we'll write here, check. They want temperature change in Kelvin. So we'll write here, since change in temperature expressed in degree Celsius or Kelvin remains same. That means your delta T is equal to 15 degrees Celsius, which is equal to 15 Kelvin. Now, how I have to prove this? I have to prove this part. So, for example, just take an example. I am taking T1 is my 27 degrees Celsius. On Kelvin scale, this comes out to be 27 plus 273. So that comes out to be 300 Kelvin. This comes out to be what? 300 Kelvin. Say T2 I am taking as 127 degrees Celsius. So 127 plus 273, that comes out to be 400 Kelvin. So I can say therefore delta T is equal to T2 minus T1, which is equal to 100 degrees Celsius, which is equal to 100 Kelvin. So I can say temperature difference expressed in degrees Celsius or Kelvin remains same. This is the first one. Now we'll go with the second sum. The second sum I am writing here. Calculate the heat capacity of a copper vessel of mass. Heat capacity is C dash. Mass is given as 150 gram. Okay. Now since your C ka value is given as 410, that is specific heat capacity, but it will be in joule per kilogram per Kelvin. Therefore, you have to convert this is 150 upon 1000 kg. Right? C value is given as 402. Now in B part, what is given? Delta T is given as, it is 35 degree minus 25. That comes out to be 10 degrees Celsius. So there are two things. First they want C dash and second they want Q. Right? So first part में can I write C dash, this is A part, is equal to M into C. Now your mass is given, it is 150 upon 1000. C will be how much? It is 410. You will get something joule, that comes out to be 61.5 joule per Kelvin. It is joule per Kelvin. Now they want Q. Since we have Q is equal to MC delta T. Instead of MC, I will write C dash delta T. C dash is your 61.5 into delta T will be 10. That comes out to be 615 joule. This comes out to be 615 joule. This is an important limit. Now we'll go with the next sum. That is third one. Now check what is third question is. In third sum, what is given? In third, you have a piece of iron of mass 2 kg, right? So your mass is given, which is say 2 kg. Heat capacity is a thermal capacity, C dash, is 966 joule per Kelvin. Then heat energy needed to warm it by delta T is given as 15 degrees Celsius. Now what they want here, first they want Q and next they want C, right? C is question. So first of all, I can go with Q is equal to C dash delta T. C dash is your 966, delta T will be 50. That comes out to be 14490. This is joule. And then C dash is equal to M into C. So I can write here C is equal to C dash upon M. C dash is your 966 upon your M, that comes to be 483 joule per kilogram per Kelvin. This is joule per kilogram per Kelvin. Right? Now we'll go with the fourth question, fourth numeric. Calculate the amount of heat energy required to raise the temperature of mass is given 100 gram, which is 0.1 kg. This is the mass of the body. Delta T is given as, this is 70 minus 20. That comes out to be 50 degrees Celsius. Specific heat capacity, that is C, it is 390 joule per kilogram per Kelvin. Right? So they want Q. So Q is question mark. So Q is equal to MC delta T. M is your 0.1. C is 390. Delta T will be 50. If you solve this, this comes out to be 1950 joule. This is your question number 5. Right? We'll go with now fifth question. This was question number 4. Now we'll go with question number 5. What is fifth question? 1300 joule of heat energy means Q is given, which is 1300 joule. Supplied to raise the temperature of mass is given 0.5 kg. From delta T is given as, it is 40 minus 20 degrees Celsius. Calculate the specific heat capacity, C they want. So Q is equal to, this is MC delta T. Your C is equal to Q upon N delta T. Q value is given as 1300, M is 0.5, delta T will be what, 20. This comes out to be 130 joule per kilogram per Kelvin. It is joule per kilogram per Kelvin. Right? Check the sixth one. What is given in sixth question? Find the time taken by 500 watt of heater. Right here, power is given. How much? 500 watts. Then mass is given, which is 50 kg. Mass will be 50 kg. Material or specific heat capacity, that is C, 960 joule per kilogram per Kelvin. Right? Delta T comes out to be, this is 38 minus 18, which comes out to be 20 degrees Celsius. Now what they want? Find the time taken. So they want T. Right? Now we have, since power into time is equal to MC delta T. Your power is 500 into T. Mass is your 50. C is 960 into delta T will be 20. So if you solve this, you will get your answer something in seconds. Right? Then you divide this number by 60. So that your answer will be in minutes. Right? This is your, if you solve this, this comes out to be 32 minutes. कितना आएगा 32 minutes. That is your answer. Okay? Now we'll go with the seventh question. What is seventh question? Question 7 is very easy, similar pattern. Electric heater of power, that is P is given, which is 600 watt, raises the temperature of mass is given, which is 4 kg. The delta T is from 15 minus 10, which is 5 degrees Celsius. Then time is given as 100 seconds. Time will be 100 seconds. Calculate the heat capacity C dash. Calculate specific heat capacity C. So I can write here, since your power into time is MC delta T. Right? So power is given as 600. T is given as 100. M is given as 4. C we want. Delta T will be say 5. So if you solve this, your C comes out to be 3 into 10 raised to 3 joule per kilogram per Kelvin. Now they want C dash. Now since C dash is equal to M into C, M is your 4 into 3 into 10 raised to 3, which is, I can write it as 1.2 into 10 raised to 4 joule per Kelvin. Is joule per Kelvin. This is about the cell. Now check the question number 8. What is given in question number 8? In 8th numerical, 0.5 kg, that is mass, is given as 0.5 kg. At T1 is given as 30 degrees Celsius. Placed in a refrigerator which can remove heat at average rate of, that is power, 30 joule per second. This is your power. T2 is given as 5 degrees Celsius. T2 is 5 degrees Celsius. What they want here, find the time. Specific heat capacity is given as C, 4200 joule per kilogram per Kelvin. Right? Here also I can use, since your power into time is equal to mc delta T. Right? So this is your power, which is 30. Time is unknown. Mass is 0.5. This is 4200. And delta T will be, it is 30 minus 5. So if you solve this, you will get first, it will be in seconds. And you divide this by 60, you will get something minutes. That will be your 8th answer. That is 29 minutes 10 seconds. Right? We'll go with the 9th sum. 9th type is different. Just check. In question 9, what is given? A mass of 50 gram of certain metal. So your mass of metal is given. So I write this is 9. M1 is given as 50 gram capacitors. T1 is given as 150 degrees Celsius. Right, C1 they want specific capacity of this metal. Immersed in M2 दिया हुआ है, which is 100 gram. Right, T2 दिया हुआ है 11 degrees Celsius. C2 is water with a 4.2 joule per gram per Kelvin. And what they want here, temperature of mixture T दिया हुआ है 20 degrees Celsius. We write here according to principle of calorimetry. Right, heat lost by hot body is equal to heat gained by cold body. Heat lost by hot body is equal to heat gained by cold body. So I can write this part. This is equal to your M1 C1. It is T1 minus T. This is your M2 C2, T minus T. M1 is your 50, C1 is unknown, T1 is your 150, minus T is 20. This is M2, which is 100, C2 is 4.2. This is equal to 20 minus 11. If you solve this, this comes out to be C1 is equal to 0.582 joule per gram per Kelvin. This is very important because the calculation is little different, right? Check the question number 10. In question number 10, similar pattern. What is given? 45 gram of water at 50 degrees Celsius. M1 is 45 gram. T1 is 50 degrees Celsius. Your M2 is given as copper, which is 50 gram. T2 दिया हुआ है, it is 18 degrees Celsius. Right? Final temperature they want, that is T they want. T is question mark. Specific capacity of water, that is C1, is 4.2 joule per gram per Kelvin, and C2 is given as 0.39 joule per gram per Kelvin, right? So I can write here according to your principle of calorimetry, right? Heat lost by hot body, heat lost by hot body is equal to heat gained by what? Cooled body. Now if you solve this comes out to be your M1 C1 T1 minus T, M2 C2 T minus T2. Now M1 is given as 45, C1 is given as 4.2. This del T1 matlab 50 minus T is equal to, this is 50 into 0.39 into this is T minus 18. Right? If you solve this entire part, this comes out to be T is equal to 47.007, right? Which is approximately written as 47 degrees Celsius. This is your answer. This is your answer. 10th. Now we'll go with 11th. 11th is exactly similar pattern. 11th will be exactly similar pattern. Now just check what is given in question number 11. Now 11th question, what is given? 200 gram of hot water, means M1 is given as 200 gram. T1 is given as 80 degrees Celsius. Mass of cold water M2 is 300 gram, and your T2 is given as 10 degrees Celsius. Now temperature of mixture T is question mark, and your C1 is equal to C2 because water here, this is hot water, this is cold water. Now write here according to principle of mixture. According to what principle of mixture? I can say heat lost by hot body is equal to heat gained by cold body. Right? Cold body. So I am writing this part. This is equal to your M1 C1 T1 minus T. This is your M2 C2 T minus T2. Your C1 and C2 is same, cancel. So this is your 200. This is T1 is 80 minus T. 300, this is T minus 10. I can cancel this 0, 0, which is multiply. Like T is equal to 38 degrees Celsius. This comes out to be how much? 38 degrees Celsius. Right? Now we'll go with the 12th. Only two numericals are there. The temperature of 600 gram of cold water, this is M2, rises by 15 degrees Celsius, that is delta T, when 300 gram of hot water. So M1 is 300 gram, right? Your T1 is 50 degrees Celsius. T1 is 50 degrees Celsius. Then M2 is 600 gram. T minus T2 is 15 degrees Celsius. T minus T2 कितना होगा 15 degrees Celsius. Here also water is same. C1 equal to C2. What they want here, T2 is question mark, right? So we write here same part according to principle of calorimetry. Right? I can write directly now. M1 C1 T1 minus T, M2 C2 T minus T. C1 C2 cancel हुआ. M1 is your 300. Right? T1 minus T1 is 50 minus T. This is your 600 into what 50. This is 1 za, this is 2 za. So 50 minus T is equal to 30. So your T is equal to 20 degrees Celsius. T is equal to what? 20 degrees Celsius. Now since your T minus T2 is 15 degrees Celsius, so I can write here this is 20 minus T2 is 15 degrees Celsius. I can write T2 is equal to 5 degrees Celsius. This is your important part. Now we'll go with last sum of this chapter, of this part, right? Now check. What is the last question? 6. In last question 13, a 1 kg mass is given as 1 kg. Contained in a 1.25 kilowatt kettle, that is power is given 1.25 kilowatt. This is 1250 watt. Then delta T जो है, that is 100 minus 25, which is 75 degrees Celsius. C का value is given as 4.2 joule per gram per Kelvin, which is 4200 joule per kilogram per Kelvin. Right? What they want here? Time. T is question. So we'll write here, since power into time is equal to mc delta T. Right? So your T is equal to, this is m is 1, C is 4200, delta T is 75 upon this is 1250. If you solve this comes out to be 252 seconds and this comes out to be 4 minutes. Right? 4 minutes 12 seconds. This is your answer. That's it for this video. Thank you so much. Next lecture, next week, we are going to start with the calorimetry part B, which is very important, along with the numericals. Thank you so much for your coverage.